Okay, let's finish up lesson 10.3. This is part 2. Here we go. Got a little idea for you here. It says this. It says if these two chords are equal, these are the two we're looking at. This chord here, CD, and this chord here, AB. If they are equal lengths, then we know a couple things. First of all, it means they're the same distance from the center. They are the same distance from the center. If the chords are the two are the congruent. If the chords are congruent, the blue chords, if they're the same length, then they're the same distance from the center. Also, it also means that these two arcs will be the same. That will be equal to that. The same number of degrees for that yellow arc, same number of degrees for the other yellow arc. Again, if the chords are the same length, then they're the same distance from the center, and the arcs will be the same also. Let's go do a problem somewhat similar to that. Boom, there it is. Okay, it says find the value of x. Well, what do we got? Well, look at the 9s. Oh, those two chords, look, and they're not just any distance, they're the perpendicular distance. Oh, they're the same. Look at that. Boom, they're the same. Hey, if they're the same, then what do we know? Yeah, we know that these two chords are going to be the same length. Okay, you set it up and solve. Here we go. We'll do it in red. Hey, we know now, because those chords are the same length from the center, we know that 15x minus 25 has to equal 35. Okay, wow, let's see, do algebra. Plus 25 here, plus 25 here. Gone, gone. We got 15x's here. What do we got, 60? Oh, nice. Divide by 15, divide by 15. X equals 4. Do they want us to do anything with it? A.J. Ellis, what do you think? Can they want us to do? No, they don't. Here we go. Boom. There it is. That's all they wanted. Again, why do we know that the two chords are the same length? Because they're the same distance from the center. Okay. Let's go back over here and let's look at this little idea down below. Okay, now, here's our center. Our center is at Z. Okay. Now, notice what we see here. ZM, the blue segment, is the radius. Oh, notice it's perpendicular to the chord NK. If it's perpendicular to the chord, then you know what it does to the chord? What do you think? Yeah, it cuts it in half. See, there was chord NK, and our radius, because it's perpendicular to the chord, it cuts it in half. It also makes these two arcs equal. This one here and this one here. Those two green arcs will be the same number of degrees. And it's all because the radius is perpendicular. The radius is perpendicular with the chord. That's what happens. Number 1, it cuts the chord in half. Number 2, it makes two congruent arcs out there on the circle. Let's go do a problem like that. This is going to wrap it up. This is going to wrap the lesson up somewhere here. Here we go. I'll tell you what, I like this problem. L is the center right there. Okay, let's see what we got here. LR is 5. BP is 8. So this the whole chord is 8. Okay? We'll kind of do it like this. The whole thing is 8. Okay, what do you know? What do you know? Well, from what we just saw in that last picture, hey, I got a radius here. I don't know, call this point here something else. I'll tell you what, let's put it right here. We'll call it C for Chuck Sawyer. Okay, LC is also the radius. And look at it, it's perpendicular. It is perpendicular. Right there, it's perpendicular with the chord. What does that do to the chord? Yeah, it cuts it in half. This part equals this part. Oh, well, if the whole thing is 8, then this is 4, this is 4. Now, you need something else, though. We want to find LA, the little distance right here. That's what we want to find, L to A. How can you do it? I'm going to get a line ready. Anybody know where I'm going to draw in a line segment? Anybody know? Well, I'll tell you what. I could draw it in here. I can draw it in here. Those two lines that I just drew, what are they? Yeah, they're the radiuses. Okay? All the radiuses in a problem are all the same. If LR was 5, they gave that to us. Well, that's 5. That's 5. Now, how do you solve for this? LA. Call it X. Yeah, you do Pythagorean theorem. That's the key on this. You go, oh, I didn't see the right triangle. Well, you had to draw it in. Okay, let's do it. Here we go. I see x squared plus 4 squared, okay, equals, hypotenuse is the 5, the radius. Yeah, nice. X squared plus 16 equals 25. Minus 16, minus 16. X squared equals 9. Wow, root, yeah, we got it. X equals 3 right there. That distance is 3. LA equals 3, huh? What are we going to wrap it up today? Here we go. Michaela Stroll, what do you like? Yeah, here we go. Boom, right there. Some flowers. Kind of springtime. Flowers are blooming. Okay. Boom, we'll make that guy bigger in the middle. Boom. Oh, can we make it the size of the... Yeah, there we go. Nice. Okay, there's my artwork I'm leaving you with. Okay, that is the end of 10-3.